In this lesson, I'm going to talk really briefly about solving multi-step equations. You'll find this lesson particularly useful if you're in a Math 1 class right now, as solving equations is a big component of the Math 1 curriculum, or it may also be useful if you find that you're in Math 2 and still may be struggling with solving multi-step equations. Okay? So I kind of listed here in the top right-hand corner the general steps that we're talking about when solving multi-step equations. Okay? Remember, the main idea is that we just want to get the variable we're solving for by itself on one side of the equal sign. I will also note before I begin that whatever I do to one side of the equation, I must do to the other, right, in order to keep the equation balanced. So we're looking at step one is to distribute. That's where you see something outside of a set of parentheses and you need to multiply that piece in. Then after that, we're going to combine like terms on each side of the equal sign. Then once we've done that, we're going to use inverse operations, or the opposites, to move our variables on one side of the equation and the numbers on the other. And finally, we're going to simplify. So watch me work through some of these examples. I have to do step one on this first problem, distribute. I know I have to do this because I see this set of parentheses here. So identify what it is I'm going to distribute. It's that 3, which means I need to multiply the 3 times my first term, 4n, as well as 3 times my second term, which is 5. And I like to kind of write this all the way out. You don't have to do this. This is just a personal preference. So I'm going to write 3 times 4n. If you're okay to do that multiplying in your head, just go ahead and multiply. You don't need to write it all the way out. Separate with a plus sign. I return back to my 3 because that's what I'm distributing. And I multiply that by the second piece, which was 5. Everything else I'm going to copy straight down. Bring down my equal sign, bring down my negative 81. So right here, first I say I need to do 3 times 4n. That's going to get me 12n. Then I need to do 3 times 5, which is going to get me 15. Bring down my equal sign, negative 81. So now that I'm at this point in solving my equation, I kind of want to draw my little dotted line to separate both sides of the equal sign. I know that the variable I'm trying to solve for is n, so I want to get n by itself on the left side of my equation. That means there are two things I need to move away from the n. I need to move the 12 away from the n, and I need to move the 15. I'm actually going to start by moving the 15 away because it's further away from the n. If you see that 12 is very close to the n, so they're attached super tightly. It's harder for me to pull the 12 away. So I'm going to start by moving the 15 first. Okay, let me get that n back there. So this is where I'm on step 3 now, using inverse operations. I should also note there's no like terms to combine on either side, okay? Because on the left side, I have a variable and what we call a constant or a number. And then on the right side, I have a number. So nothing that's alike on the same side. So let's move that 15 to the other side. It's a positive 15, so I need to subtract 15 from both sides of the equation in order to move it. Look at how I wrote that. I wrote my like terms vertically. Now I see that I didn't do anything with the 12n, so I bring it straight down. 15 minus 15 is 0, so they cancel out. I bring down my equal sign, and on the right-hand side, I make sure to perform that subtraction problem I have written. Negative 81 minus 15. I could also say negative 81 plus negative 15, right? Because we can always add in plus signs wherever we want, just not minus signs. So that equals negative 96. Feel free to use a calculator to check. Again, I need to use inverse operations once again because the n is not by itself. I see a 12 attached to it. And I know that when a number and a variable are next to each other, it means multiplication. They're attached by multiplying. So I need to do the inverse, which is to divide. So I'm going to divide both sides by 12. So that way on the left-hand side, I have a single n left is equal to negative 96 divided by 12, which is going to be a positive 8. And there's my final answer, n equals 8. Let's scroll down to the next one here. Again, I say I'm going to have to do that step 1 because I need to distribute this negative 3. Okay, I got to distribute it first to the 1 and then to the 7p. And again, I'm going to write that all the way out just because I like to do that so I can see exactly what I'm multiplying. It's especially helpful when we get multiple pieces, like we have 3 or 4 things to distribute inside the parentheses. Then negative 3 times 7p. Bring down my equal sign. Bring down my negative 171. Okay, next line looks like this. I got to do negative 3 times 1, which is negative 3. negative 3 times 7p, which is negative 21p. I could put a plus sign there if I wanted, but I'm just going to kind of clean it up and just put minus 21p. Oops. Bring down my equal sign, negative 171. Again, now I check to see if there are like terms to combine on either side of the equal sign. There are not, so I can start using my inverse operations to move. Note, this time I have my number or my constant first, and then my variable term next, but it's still going to be the same deal where I need to move the constant term first to the other side using inverse operations. I already see it's a negative 3, so the inverse would be to add 3 to both sides of my equation. These guys cancel out. I just bring that negative 21p straight down, bring down my equal sign, and on the right-hand side I need to do negative 171 plus 3, which is negative 168. Okay, finally, I can still see that p is not quite by itself. I need to get rid of that 21. I asked myself, how is it attached to p? Well, it's attached by multiplying, so I need to divide both sides by negative 21 so that I get a single p by itself. And my final answer, I got to type this guy in the calculator, p equals a positive 8. Let's take a look at another one that's a little more complicated. Again, my first step is going to be to distribute, and I can see in this particular case that I actually have a few things on that side of the equal sign, right? It's not just the distribution in the parentheses. But I look to see what's directly in front of the parentheses. In this case, it's the 7. So the 7 is what I'm going to distribute into the set of parentheses, not the 8, because the 8 is not directly in front of the parentheses. So that's key. Okay, so what I'm going to do actually is just copy that 8 straight down. Now I'm going to write my distribution. 7 times the first thing, which is 6x, separate with a plus sign. 7 times the second thing, which is 7. Bring down my equal sign, bring down my 141. Now I'm going to go ahead and do my multiplying to simplify. So I know that 8 is going to be brought straight down. 7 times 6x is 42x. 7 times 7 is 49, equals 141. Now I'm going to take a look at both sides of my equal sign. There's only one thing on the right side, so no like terms to combine on over there for sure. But if you can see on the left-hand side of my equation, I actually have a couple things I can combine, which is kind of nice. That'll make it a little simpler. Remember, see up here, step 2, combine like terms on both sides of the equal sign. So I can see that 8 can get combined with 49 because they're both numbers, right? I either have to have the same variable and power or no variable because they're constants. So if I combine 8 and 49, I'm actually first just going to bring my 42x down, and I can combine 8 and 49 to get 57 equals 141. Okay, now I can use inverse operations to make sure I get that 42x term by itself. Again, the first thing I'm going to do is move that constant. Since it's a positive 57, I'm going to subtract 57 from both sides of the equation, bring down my 42x, that guy cancels out, equals 141 minus 57. I type in my calculator and get 84. One more step, because x is not by itself yet. The 42 and the x are attached by multiplication, so I need to do the inverse, which is division, in order to undo it. Those cancel, and I get a single x is equal to 84 divided by 42, which is going to be 2. And there we solved it. X equals 2. Okay, let's look at another one here. Again, same deal where I've got multiple things on this side, on the left side of the equal sign, but again, I'm just going to distribute the negative 6 into my parentheses because that's the first thing. This one I'm going to do a little bit quicker and not write it all the way out. So negative 6 times negative 3b is a positive 18b. Negative 6 times a positive 4 is a negative 24. I'm going to bring down my minus 6 equals negative 120. Again, I'm going to say, hey, are there any like terms to combine? There sure are. I can combine these two because they're both numbers. Be careful how you type this in your calculator. It's either negative 24 minus 6, or like I said, you can always add plus signs in. You could say negative 24 plus negative 6 in your calculator. Do not, I repeat, do not say negative 24 minus negative 6, because that actually means negative 24 plus 6, which is not similar to anything I wrote there. So my next sign looks like this. 18b minus 30 equals negative 120. Now let's use inverse operations. Again, it's easier for me to move that 30 over to the other side than it is for me to move the 18 away from the b because they're attached too tightly. So, but if I add 30 onto both sides, because that would be the inverse of subtraction, I'm going to bring the 18b straight down. Those cancel, equals negative 90. Again, finally, my last and final step is going to be to divide both sides by 18 because the 18 and b are attached by multiplication. And I get that a single b is equal to negative 5. I'm actually going to go ahead and skip that guy and go on to this guy right here. That's a little more difficult, okay? You can see now that our variable term's on the right-hand side of our equation instead of the left-hand side, but the process is still the same. I ask myself what's directly in front of the parentheses that I need to distribute. In this case, it's the 6. So I'm going to copy down negative 110 equals. I'm going to do 6 times negative 7k to get negative 42k. I'm going to do 6 times negative 7, note I include that negative sign there, to get negative 42. And then I bring down my plus 8k. Now previously we had constant terms or numbers that were like terms to combine. In this case, as you see, what's actually alike on this side is the 42k and the 8k, because they both have a k to a power of 1. So those can get combined. I'm going to bring that down, equals, when I combine those two together, negative 42 plus a positive 8 is a negative 34k. I'm going to bring minus 42 straight down. Now let's use inverse operations to get k by itself. Again, that negative 42 is easier to move first because it's further away from the k. I'm going to move that by doing the inverse, which would be to add 42 to both sides of the equation. When I do that, I'm going to get negative 68 equal to, bring that directly down because there's nothing I did with it, and those guys canceled. Again, I have negative 34 times k, so in order to undo those, I need to divide because that's the inverse operation. So I'm going to divide both sides of my equation by negative 34. I'm going to type what I see on the left-hand side into my calculator just to make sure I get it right. And it's going to tell me that k equals a positive 2, or 2 equals a positive k. And just because I like my variable coming first, I'm going to rewrite that at the very end. But both of those, they are acceptable answers. Okay, and that's how I solve that. One last thing I want to show you is how you could check your answer. So I got at the very end of that one that k equals 2. So theoretically, I should be able to take 2 and plug it in wherever I see a k in my original equation and evaluate. And I should get a true statement at the very end, like something that says, say, 2 equals 2. Or in this case, hopefully negative 110 equals 110. Okay, so this is how I write that all the way out. I'm going to say negative 110 is equal to 6 times negative 7. Again, this says negative 7 times k, so I'm going to say negative 7 times whatever k equals, which is 2. Okay, move over a little bit there. Minus 7, close parentheses, plus 8. Again, this says 8 times k, which is 2. So I'm going to say plus 8 times 2. And I like to write just a little question mark here to say, hey, are those equal? Because we don't quite know yet. That's what we're trying to figure out, if both sides are going to be equal to each other. Easy peasy, bring the negative 110 down. Let's work on some order of operations. Do what's in the parentheses first. So negative 7 times 2 is negative 14 minus 7 plus 8 times 2 is 16. I didn't technically do everything in the parentheses first, but that's okay. That's not going to ruin our order of operations. Negative 14 minus 7 is negative 21 plus 16. Now next I need to do my multiplying before I do my addition or subtraction. Okay, so I'm going to do 6 times negative 21, and that gets me negative 126 plus 16. Finally, is it true that negative 126 plus 16 equals negative 110? It sure is indeed. And since we got negative 110 equals negative 110, which is a true statement, we can be fairly confident that we solved this correctly and that k does indeed equal 2. And that's just a brief review of how to solve multi-step equations.